understand. So this is the subclasses is the job type. Depending on the job, it's classified or generalized or is the specialized. In this case, secretary, technician, and engineer by type. So each type can be represented here like the technician or the engineer or the secretary. Okay. So disjoint, constraint, disjoint or overlap can be represented by circled O or circled D. And the completeness constraint is whether this is a full or partial participation. Because my computer is 5 years old, so it's a little bit slow, but I like it. It's good for, it's easy to carry, but sometimes if I run the very heavy application, it takes time. Anyway, so this is the notation for disjoint or overlap. As you can see, this is the disjoint and this is the overlap. And the completeness, full or partial, can be represented by the double line or single line. So total, we have the 4 different cases. Disjoint, total, disjoint, partial. So total means full. Overlap, total, full, overlap, partial. So we already discussed. We saw the many times the same example, and we skip it. And what about this? Can you explain what this diagram means?
We have
first, what is it for?
it's for parts of
it's a part, right? It's a part entity. Then
part.
Mm-hmm.
We have 2 subclasses.
Yes.
Manufacturer part and purchased part.
Yes, good. Then
And, we have overlapping.
overlapping means
Overlapping means like any part can be manufactured and has a manufactured part and can be purchased part.
yes. Can you understand?
Yes.
So a part can be both manufactured and the purchased part, right? Also, is there any other part not belongs to manufactured or purchased?
No.
No, it's a full, complete, full participation. Okay, that is the things you need to understand in this chapter. Then reverse engine. This is the kind of reverse engineering from the ER diagram you can understand. So from your requirement, if you are able to create this diagram, let's see. Yes.
And from the way of thinking, it was the subclasses that generated the part.
I don't know. Either it can be specialized.
You are saying generalization.
But generalization is not mentioned here.
What about these curved lines?
There is oh yes. Oh, there is. I didn't see. Yes. In this case, it's a generalized, which means you found the manufactured part as well as the purchased part first. Yes, right. Also, one more thing you need to keep it is what is the key of this?
It's no.
Do you have a key?
No. It's weak.
Yes. Because how many entities do you have here?
One.
Just one. So for part. So you don't need the key.
Yes.
For subclass, instead you can get all the information. You can inherit all the description to subclass. So as she said, part number is the key of this. Part number is the key of this. Does it have the description? Yes, it has. Because it's inherent.
Yes.
Then we learn the super and subclasses. We are going to extend the superclass and subclass into hierarchy lattice, and union type. For example, hierarchy means, what is the hierarchy anyway? Did you take the file structure or algorithm course? What is a hierarchy?
Hierarchy is like you have a root and you
Pyramid.
have children.
Yes,
It's like
tree
a tree.
structure.
Tree.
Think about the tree structure. What is a tree structure? It has the parent node. It has children node. You can have many children, right?
Yes.
So parent and children node are the component of tree structure, hierarchy structure. So hierarchy structure comes from top to bottom using parent and children. Then how many children do you have? How many parents do you have in hierarchy? One parent, right? It has only one parent. So that is the hierarchy. So hierarchy is the previous example of hierarchy. Okay? This is not related question for this, but it's good for the computer science major. What is the A graph?
Graph, it's a part of a tree.
Part of tree? No.
Unidirected tree. Unidirected tree.
Tree.
Sorry, a graph is a full tree.
Full tree. Let me change the question. Let me ask you, which one is the more general? Which one is the superset between graph and tree? Which one is the superset? Graph. Graph does not have parent and children relationship. Instead, just connect between nodes. That is a graph. Graph is more general structure. Then tree is more specialized structure. That's very important. It's a frequently used in many applications, many programs, many algorithms. But sometimes many students confuse what is the difference between graph structure and tree structure. Then hierarchy is a tree structure. Then how many parents do we have? Only one parent. What if more than one parent? Is it possible? Yes, sometimes possible. Think about the real life. So I have the biological parent. I have adopted parents. I have actually the parents for my baptism. When I got baptized, there's another types of parents. Whether or not you in Roman Catholic, there's another types of parents. It's religious parents. Okay. So sometimes we can have many different types of parents. If you allow such a multiple parents relationship, it is called lattice structure. So lattice means, because my previous class when I pull over the this one, actually it's a detached. So I'd like to be careful. What is this? It's one. It's a graph.
A graph.
It's just the node and edges. However, if we have what is this?
Tree.
It's a tree structure. Parents, children, parents, children, parents, children. How many parents? One parent. It's a hierarchy structure. What if?
Graph.
It's not graph because it is directed to parents and children relationship. So it's not actually it's a graph, part of graph. But specialized graph, this is called lattice. Lattice structure. Okay? Which means it allows multiple parents. Then why don't we adapt this idea to our database modeling? Yes.
How can we understand multiple parents here? Where's the multiple parents?
This is the parents of the child, right? This is another parent. You can inherit the both characteristics. Then, what can be the example of in our the real database? What about the university database? Is there any subclasses inherited by multiple parents? Think about him, our Ch8. Ch8 is student.
And he's an employee.
Yes. Ch8 is both employee as well as a student. So he can be inherited by both employee and student. How many parents? 2 parents, right? So it is called a lattice structure. So let's take a look at the example. Here, this is the hierarchy structure, okay? And then we have the examples. Oops, it's very slow. Okay. One more. Yes. Why don't you take a look at the student assistant, right? The other we already. First, my question is, how many entities do you have? This. How many entities? 1, 2, many?
We have one.
One. For what? Person. This is a person entities. Then we can create many subclasses, even subclasses of subclass. Yes, that's possible. Like the employee, then staff. Also, subclasses to person, employee, student assistant, and teaching assistant. 4 levels of the super and subclasses. Then, why don't you take a look at the student assistant? What is the parent of it? It's a 2, employee and student. So this is called multiple inheritance. Okay? Also, it's called the lattice structure. Then, in this case, what is the key of the student assistant? What is the key? It's a social security number. The person. Key of person. Superclass. Okay? The last one is the union type. So far, even though the one subclasses can be inherited by multiple parents, which means it's a multiple parent. Each parent is one entity. Each parent is one entity. For example, in our previous example, student assistant, we have 2 parents. One is the employee, another one is student. They are one parent. One parent has one entity. So employee has one entity. Student has one entity. Sometimes a parent can be multiple entities. Can you understand? Let's take a look at the example, then you can easily understand. This is the ER diagram for ownership. So, have you ever purchased a car in the United States? The financing is very popular here. You don't have to pay off everything in a cash one time when you purchase it. Sometimes you can get the loan. So when you purchase the car with financing, so how many owners? In your title, your name is not the only name. So the finance company, your bank, will be another owner. So there are many types of ownership. For example, here, owner is inherited by the one superclass. These are the superclass, but superclass has parents, has different types of parents. It's only one parent, but with different type. So far we have learned one superclass and many subclasses. But here, actually this is one superclass. But that superclass can be classified. It's a type of superclass. Person, it can be person, me. And it can be bank. Bank own the car because of financing. Also, company. Even though there is another type of finance when you buy a car, the Toyota provide the finance. Even though that is not a bank. You can get the loan from independent bank. Then you can get the loan from the manufacturer. That is the another type. All of them are parents, but different types. It's called the union type. It's a category, in other words. Okay? What about this? Here, so we can use to differentiate with super and subclass. Sometimes it's confused. So we can use the U to represent union type. So similar here, car and trucks are actually the superclass of registered vehicle, but it can be categorized. So types of the car using the union type. Yes. So this is a subclass. This is a superclass. Okay, but superclass consists of many types. Like this is ownership. Ownership. It can be personal, individual. It can be company. It can be the bank. So to represent such a different ownership, we can use union type. So by combining three entities, actually these are the different entities. It can be one superclass, ownership. Then inherit all the information to the owner. How can you recognize it? Because each of them has their own key attribute. Which means this is one entity, this is another entity, this is another entity, but all of them are ownership. Then inherit to the owner. So it's called a category or union type. Okay? Not frequently used, but it's sometimes you need such a modeling.
So we don't have to use the double line.
Something like this?
Oh yes, we can use the double line, single line. For example, we need to go to the previous. Yes, for example, bank is a double line here. Actually, I think it's a vague, but it's a double line, which means bank should be owner. The other person, if you pay something, you are the owner. You have the ownership. So it's it can be part of, but it's so optional. Company. It's optional. You can get the loan from the company manufacturer, but this is a full double line, which means in this case, when you own the car, which means you should get the loan from bank in this case. However, in this the union type, car and truck, both of them are it's not full time, which means sometimes there might be registered vehicle not belongs to car, not belongs to truck. It's just the other types. Okay. So this is the complete example of the university. Okay, from the person is subclasses, student and faculty, and so on. So if you can understand this, it's not very clear. So your handout has the ER diagram. If you can understand this ER diagram, probably you are able to create such an ER diagram from the requirement. That is the reason to understand the requirement itself. In other words, when you are doing our group project, the most important thing is whether or not you understand your project. So that is the reason I asked you. First, you guys discuss first regarding to the topic. Some of the team asked me, can you suggest, Professor Lee, can you suggest a project? Yes, I can. I can suggest based on my preference, my hobby. That's not a good way. So first you can list up, discuss about your topic, then you can ask me whether this is doable, this is difficult, this is easy. Any comment? Yes, I can do that. That's the much better way to select a good topic in your project. There is a formal definition. I'm not going to go through the formal definition of ER, but I'd like to emphasize on the formal. He said, what is the formal? What does formal mean? What is the opposite of formal? It's informal. Informal, actually. The English is crazy sometimes. Informal or informal. In this case, informal. English is not very structured language. It's a very the linguist. Sometimes it's for convenient. So sometimes without any reason we use the incomplete, for not incomplete. Nobody knows why we use incomplete. So informal. What does that mean? Informal in computer science. What does formal mean in computer science? Which means so far we discussed about the ER modeling informal way. Yes, it's the informal way. What does it mean?
Not specific.
Not specific?
Formal should be like involving equations.
Yes, getting close. Mathematics.
Math.
Formal way means it's a mathematics. Actually, in computer science, the only way to prove or to show the algorithm or concept is a formal way, mathematical way. Why? Actually, the computer science is a branch of mathematics department a long time ago. This comes from the mathematics. However, if I explain all the concept in the data and database modeling, formal way, nobody understands. Okay? So that is the reason sometimes we use the informal way, just to describe. What is the entity? Entity is blah 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 blah. Sometimes vague, but it's easy to understand. So if you try to study more, or if you are interested in the data modeling, definitely you need to understand the formal definition. Okay? Then if you have the new idea for data modeling, it's an object relational database modeling. At that time, you should present your idea using formal way. If you present informal way, even though your idea is the rocket science, brand new idea, but nobody believes it. Okay, so only formal way will be accepted. But I'm going to skip the formal definition part. Definitely, as I introduced the last class, the UML modeling technique can be used to replace the ER modeling. Okay, that's it. Then, I'd like to talk to you one more example that I experienced when I got a first job as a database administrator. So I joined one of the projects in my old bank, and at the time, so I had a meeting with my project manager. I entered his room. His room is half of this classroom. Then all three sides of his office were covered by ER diagram. So at that time, the database has more than 2,000 entities. Then he print out the folder, the ER diagram, then stick on the wall. Then even each entity is almost impossible to read the attribute. Then can you write like this way to manage the more than 2,000 entities? No, it's not impossible. So that is the reason we try to use tools or software for modeling. The example of such a software is Irwin software or rational rules. or Visio. There are many modeling tools. Not only for the data modeling, that include software engineering model. It covers entire process of your project, like the rational rules. When you model your project using rational rules, it creates all the components. What you guys need to do is customize. So that's the reason the rational rules is one of the most expensive software. It's used in the software engineering class. So in our class, we'd like to focus on data modeling. So we are going to use Irwin software. Irwin software is one of the most popular software worldwide. Even I used 15 years ago, the Irwin software. So Irwin software. So we will learn. We will use the next class, so you don't have to come to classroom on Thursday. Instead, you should go to the 163, the technology lab. However, I'm not sure whether you realize the projector in that room is broken right now. So if the projector is not fixed until that time, I'm going to move our classroom into the one of available. I'm going to post the notice in case we need to move. Otherwise, you can come to the 163. And at that time, we will learn how to use Irwin software. So Ch8